Okay, great, Tens. Welcome back. Thanks again for all your submissions. I really appreciate it. So we're going to go through today is the nervous system. This is going to be a little bit different than what I went over during some of the breaks, some of the optional material. Because we're streamlining the curriculum a little bit, we're just kind of touching on some of the major parts of the nervous system. So it's going to be a two-part lecture, and this is all we're going to discuss this week is the nervous system. So you can follow along on page 104, but we're not exactly covering the exact material out of the textbook. I'm more asking you to kind of just follow along my lecture, but you can use the textbook as a reference. Okay, so let's go through the nervous system. So here's the basic purpose. We've previously discussed all kinds of different systems. We discussed the digestive system, we went through the cardiovascular system, the respiratory system, and then finally the musculoskeletal system. Now, these systems all need to work together, okay? You don't want your digestive system running all the time, okay? We don't have our digestive system processing food if we don't have food in our body. We don't have food in our body at all times. You know, we have these periodic times when we have in between meals. So we have to be able to turn on and off our digestive system. Okay, well, who's turning that on and off? Okay, well, we're going to talk about that. It's the nervous system. The cardiovascular system, we talked about your heartbeat. And sometimes you have to pump your heartbeat faster. Sometimes you have to pump your heartbeat slower when you want to relax. Who's controlling how fast your heart beats? Well, again, so coming into the nervous system. The respiratory system, again, breathing. Sometimes we have to breathe faster. Sometimes we have to breathe slower. Again, coordinated from the nervous system. And the musculoskeletal system. So if we want to move, okay, who's coordinating all of our movements? And movements are very complex process. If you think about even, say, walking, you have to flex numerous different muscles at different times, at different strengths. And then if you see a little bump in the road, you have to, again, alter your flexing in your legs. And who's coordinating all of those muscle coordinations? That's all the nervous system. Okay, and if we don't have all these systems coordinating properly, this is what you're going to essentially die. And that's really what death is when the nervous system shuts down, specifically the brain. That's when you die. Some people think it's when your heart stops. It's not when your heart stops. That's just a very important system, but it's not necessarily death. Death is classified as when your brain stops, when you stop having brain activity, okay, because it's coordinating all the systems. So that comes into what the basic purpose is. The nervous system is responsible for coordinating all the systems and making sure they work together properly. Okay, the nervous system is the control center. Now it monitors the outside, like what's the environment around me? What's the temperature? Who's in front of me? Is there any danger around? So it monitors the outside, but it also monitors the inside of your body. Like, do I have a stomach pain? Is there any bacterial infection inside my body? So it monitors both the outside and inside of your body, and then starts making adjustments to help. Okay, so there's only a few basic parts to the nervous system. Let me just grab my highlighter here. So we have the brain, okay, and that's at the very, very top here. I'm just use a different color here. So the brain's at the very top. Now, the other main part is the spinal cord. Now, the spinal cord runs right down our back, okay, and it's inside vertebrae, which are the bone part. So this is actually like it's a mini brain is what you can kind of think about it. It was a primitive brain before we actually had our main brain. We actually had the spinal cord because it can do very, very simple brain tasks, but it can't do anything as complex as our actual brain. And then finally, the last thing that we have are the nerves. And all the nerves are all these kind of yellow things that you see in the picture here. These are all basically nerves. Okay? And all nerves do is they basically feed. They feed into the spinal cord and into the brain. Okay? They're just kind of their mechanisms to send information to the spinal cord and the brain and then receive or send information back out. Okay, so how it works. This is the main idea. Now, I am simplifying this, but this is grade 10, so we will get a little bit more complex in grade 12 when we take it. But this is the basic idea of how the nervous system works. The first thing is sensory information. What I mean by sensory information is like if you see, say, a ball. Okay, so your eyes see a ball, okay? Or if you hear, say, a musical note, okay, and your ears hear that musical note. Or if you touch something, say something hits your arm right there, okay? Or say it's really, really hot right here, okay? Those are all senses. Now, how we realize that there's a ball right here is that we see it. Okay, so we see it and our eyeballs pick that up, and then there's a neuron that will send that information to your brain. Just like if something touches your hand right down here. Okay? Why you know that something touched you is basically a message was sent, and we call that a sensory message, gets sent all the way up here into your spinal cord and then up into your brain. Okay? If you feel that it's hot right over here on your, I guess this would be your left hand. Okay? If you feel that it's hot on your left hand, how you know it's hot there is that there's a sense, basically a little neuron that's basically sending a message up your arm to your spinal cord and to your brain, and then your brain realizes, oh, it's hot. Okay? If you hear music, okay, your ears are going to pick that up, and it's going to send that message to your brain. Okay? So that's what sensory information is used to create a message that gets sent to the spinal cord and then to the brain, which we call the control center. And once it gets to the brain, then it uses this information to formulate a response. Okay, so it got the information that it was hot, it got the information that something touched you, it got the information that you saw a ball or that you heard a musical note. So it gets this information, and then your brain is the one that processes it. It's the one that tells your body, oh, that you're listening to music, or that's a ball, or something's touching you, or that your left arm's hot. Okay, all this is an information, but the neurons cannot interpret it. Your brain has to interpret it. Now, the last thing. Sometimes we don't do anything. We stop there. We just think about it. But what if we want to respond? What if we actually want to do something like, oh, a ball's coming. I'm going to make sure that my hand comes flying up to make sure that it blocks so it doesn't hit my face. Well, who controls that? Well, your brain does. So once the brain receives the message, the ball's coming, it will think about it. Then it will send a message out, and that's what I'm kind of showing in blue, down your body into your arm saying, arm, move up and block this ball. And it has to do this, it's very complex. It has to do it at the right time. Maybe we're flexing all these different muscles, coordinating it, making sure that you get your hand up there to block that ball. Okay? If it's hot over here, okay, and you want to move that hand, your brain would send a message down your arm into your muscles and say, move your arm out of the way. Okay? So that's the basic system of how the brain works. Okay? Is we basically get a message, it goes up to our brain thinks about it, and then it sends a message back down. Okay, so we're going to talk about the three things. The first thing we're going to talk about is sensors. Now, there's sensors all over your body, okay? But they're not evenly distributed. Okay? We have a lot of sensors in our hand. If you look at the palm of your hand, you have a ton of sensors just underneath your skin. So if you look over at the diagram kind of that I have here on the right, okay, this is kind of a diagram of what your skin would look like, okay? And all these little things that I'm kind of showing here, and I'm just going to highlight this in a different color here. All these little things that I'm highlighting in blue are all little sensors that are inside your skin. So you have some sensors that are going to feel pain. You're going to have some sensors that can feel touch. You're going to have some sensors that feel cold, some sensors that feel hot, and they're all underneath your skin. But it's not evenly distributed. And what I mean by that is if you cut your hand, you're going to really feel it. It's usually a very painful cut, cutting the palm of your hand, because you have a lot of these sensors. And you need to have all these sensors because we use our hands all the time. We need to be very sensitive to touch. However, in other areas that we don't use very often, say like the back of our shoulder, we don't have a lot of pain receptors. And if you've ever, say, sometimes looked at your arm or looked at your leg and you're bleeding and you realize, geez, how did I get cut? I didn't even feel anything. The reason why you didn't feel it is you probably got cut in an area that doesn't have a lot of sensors. And it usually happens on things like your legs, your back, areas that normally don't touch things and don't need to have all those receptors. Okay, so what sensors are they're just kind of all throughout our body, and they get information. Right? So that's our eyes are sensors, our ears are sensors, our taste is sensors, our touches are all sensors. Okay, and all these things basically send information back to our brain about the environment around us and about also what's going inside. So an example that I have down here is like, say, your eyes telling you that danger is approaching. Okay, so you look and you get that information that something dangerous is now coming to approach you, and you send that message back to your brain. Okay, or another example is, a classic example of your skin telling you, oh, it's really, really hot outside. Okay, it's starting to pick up a lot of heat here, and it sends that message back to your brain saying, there's some heat coming on here. Okay. All right. So I'm just going to kind of draw a picture of what's happening here with sensors. So basically, you're feeling something, it comes down, back to your spinal cord, and up to your brain. Okay, another, you sense something in your other hand, you sense something in your hand, goes up your spinal cord, into your brain. You see something, it goes through the nerves inside your head, and then into your brain. Okay? If you feel something in your leg, it will go up your leg, all the way to your spinal cord, up your spinal cord, and then into your brain. Those are sensors. Okay? Now we're at the brain. So what's our next? We call it the brain, or we also call it the control center. And the control center is where the message from the sensors is interpreted, and a plan is developed as to, interpreting this information. What should I do? Do I need to do anything? Do I just need to think about it? Now, it's normally the brain. Usually you're going to go all the way back up to the brain. But there are certain times where we don't have time to actually go all the way up to the brain to interpret, and we just go to basically the spinal cord and then right back out. So most times, I'm going to do this first one in red. Most times it goes like this. You feel something, it goes all the way up your brain, into your spinal cord, up your spinal cord and then into your brain, okay? And then your brain takes that message and then sends the message back down your spinal cord and into your arm. Okay, that would be the normal sequence. However, if it's like an emergency where you don't even have time to get it to your brain, what will happen is the message will go up your arm, it will basically hit your spinal cord, and then go right out of your spinal cord right back down. Now that's what we call a reflex. Those are what reflexes are. Reflexes are basically the message is going just to your spinal cord and then right back to your arm without actually going to your brain. And they're used for things that are, emergency. Like you touch a hot stove, you don't have time to send it to your brain to interpret, oh, I'm touching a hot stove, I need to remove my hand. Your spinal cord takes care of anything really, really an emergency situation. It will take care of it for you. So, some examples. So the sensor, the eyes are telling you the danger is approaching. The control center creates a plan. So this is your brain now thinking, okay, I need to run away. And the sensor would be your skin telling you it's hot outside. And then the control center would say, let's create a big plan and let's start sweating. Okay? So that's what the brain and the spinal cord do, or our control centers. If we go back to our diagram here, we sensed something. I went up my arm, up my spinal cord into my brain. Okay, and now we're at the point where my brain now thinks about something and now formulates a response. So now it's the next step. All right, the response. Okay, so now the brain or control center then sends the response in the form of a message from the brain to the spinal cord and then to the area of the body that needs the message. So you get that and you say, okay, I want to now move my arm. I got the sensory information. I'll do this in green. So sensory information comes up. Okay, I want to move my arm. Okay, now I'm going to send that message down my arm again to move my arm. Okay. All right, so let's go through a whole sequence. The sensor, the eyes tell you the danger is approaching. The control center, let's create a plan and run away. The response, the message goes down to your leg muscles and then you start moving. Okay. Or another example, the skin. Here's the sensor. The skin is telling you that it's hot outside. Your brain or your control center says, let's create a plan to begin sweating. The message then goes to the skin and you begin to sweat. Okay, and that's the kind of Okay, so let's look at this example from the very beginning. Okay, so let's say that you have a tennis ball. Okay, and the tennis ball is being thrown, and you see that ball and it's coming towards your eyes. Okay, so that's the sense. Okay, so you get the sensory information. And the sensory information comes from your eyes, and you are going to send that information to your brain. Okay. Gets to your brain. Okay. So now we've gone from the sensor, which was our eyes, and now we're getting in our brain. Our brain says, okay, there's a ball coming towards our eyes. We now need to initiate a movement, okay, because I need to block this ball from hitting my head. So what I will do is I will send a message now down my spinal cord, down through my arm, through this muscle, my biceps, then also all kinds of different muscles all throughout my hand, which is then going to cause my hand to swing up and block that ball from hitting my head. And that's the idea between sensors, control center, and the response and how things work. One of nerves. If you have any questions, let me know. Okay, so that's it for